Assalamualaikum warahmatullahi wabarakatuh. My name is ZULHILMI bin Mohd IZHAR. Today, I will present to you about development of lattice structure for laser powder bed fusion. So before to begin with, let me introduce to you my supervisor, which is TS Dr. Muhammad Syariman bin Adnan. So for the summary, lattice structure are defined in the literature as an object periodic in the nature. So lattice structure is a repeating unit cells that interconnect in the 3 dimension. The most common lattice structure is a strut base, which is SB, and the triply periodic minimal surface, which is TPMS. So this for this project, tensile specimen is modeling using computer aided design and utilized in the open software to generate manufacturable lattice structure. Last but not least, finite element analysis is executed in order to predict mechanical strength. Next, we go to this overview of presentation. We will cover about introduction, literature review, problem, statement and objective, methodology, and last but not least, preliminary result. For introduction, I will start with additive manufacturing. Additive manufacturing permits the manufacture of a strong, lightweight material with a geometry that traditional manufacture process cannot achieve. That's its definition of additive manufacturing. Then literature review. So I have 4 literature review that revolve in this presentation, which is lattice structure, additive manufacturing, metal additive manufacturing, laser melting. So for the lattice structure, literature review is a method of constructing lattice structure, typically automatic. So the end of unit cell have a face removed and then interconnect to other cell using Boolean technique. A wide variety of cell topologies divided into 2 groups, which is early that I stated, strut base and the TPMS. So most commonly used is a BCC, which is body centered cubic for strut base, face centered cubic for strut base. For gyroid, swords, and diamond, most common lattice structure that found in the TPMS. For additive manufacturing, literature number 2 is I find that additive manufacturing is involved laying down material in a 2-dimensional layer, then placing a subsequent layer on the top. This technique will repeatedly until project finish. Additive manufacturing also is more adaptable and precise than traditional manufacturing method because they can manufacture lattice structure by only placing material where it is needed and joining multiple layers of lattice structure together without any strength and flexible post processing. For next literature review is a metal additive manufacture. So lattice structure can be found in a metal additive manufacturing, which is using powder bed fusion method. Most common powder bed fusion method is SLS and SLM. So the metal additive manufacturing industry has surged in the 3D printing technologies with a highly advanced device and method. However, the metal alloy that can be reliably printed is minimal. For the last literature review is a selective laser melting. So in this journal, I found that SLM fabricate lattice have a common titanium lattice structure, stainless steel, aluminium. That is a alloy that can be found in SLM. SLM also have a several fall, distortion, cracking with highly heat stress. So the poor surface finish could be the result of the baling effect. Porosity also can you found in the selective laser melting, as you can see on the diagram. So this is a porosity that found in the material that produced by SLM. Next, I will go to the problem and objective. So my problem statement, which is the produced lattice design is challenging by conventional manufacturing technique. So it requires an additive manufacturing to create its complex cross-section structure. Rapid prototyping technique called SLM creates a complicated design that are impossible to construct using traditional manufacturing technique. So for my objective for this FYP is to design tensile specimen and geometrical model using CAD software, to generate manufacturable lattice structure using numerical software. Last but not least, to implement lattice structure on the tensile specimen and stimulate the mechanical strengths using finite element analysis. For my methodology, this study start with reading the article about lattice structure. Then the problem statement and objective be found after lattice structure is acknowledged. The problem of this research encounter was inability of conventional method to manufacture lattice structure. So as a result, AM is more reliable to produce this material for lattice structure. Then, according to ASTM, standard dimension was followed to design the tensile specimen. Next, a model of lattice structure will created by using numerical software, which is topology. Then the design that I choose have a 3 design, which is gyroid, swarth, and diamond. Then I will use Simufect forming to test on a simulation tensile testing. So for preliminary result, lastly, we go to the preliminary result. So for the preliminary result, I use 3 software, which is CATIA, topology, and Simufect forming. So for modeling tensile model, I use standard worldwide ASTM International for designing sheet type metal. So I use these parameters and dimension to design this model in CATIA. So while I'm using this CATIA, I have prepared this 3D design, which is have a length of 200mm. So 82.15 is my designing space for lattice structure to be used in this area. Next, for the result, I have done a 3 design, which is gyroid, swarth, and diamond. So for the gyroid, this is a unit cell that I use in a topology. Topology is one of software that I use to get my result. So for gyroid, this is a unit cell, and this is the result that I apply on the tensile specimen. Next, I use SWOTs. This is a unit cell of SWOTs. Then this is the result for the model on the tensile specimen. Last but not least, a diamond TPMS. So this is a basic unit cell, a one unit cell, and this is a result in topology. So for this unit cell, the cell map I choose, a cell size that I choose is a 5 meter times 5 meter millimeters, 5 millimeters times 5 millimeters times 5 millimeters for the cell maps that occur in this area. So for this semester, I have done objective 1 and objective 2. For objective 3, I cannot proceed because Simufex forming need to buy their license to start our FEA. So perhaps I can continue these studies to the next semester, which is final year project 2, to implement lattice structure and tensile specimen and stimulate this mechanical strengths using finite element analysis in Simufex forming. So I think that's all for me. Thank you to give me this opportunity.